take a long time to solve actually. Okay. For solving such type of problem, we can use a backtracking approach. In this backtracking approach, first we want to study what is the approach. Okay. Then what is the control abstraction of that approach. Okay. Next, we want to study the N-Queen's problem. Okay. There are in the syllabus, using the backtracking approach, we can solve N-Queen's problem. Okay, this we want to study. What is N-Queen problem and how it can solve using backtracking approach. Then 0 bar 1 knapsack problem. We already familiarized what is 0 bar 1 knapsack problem. We want to solve that problem using the backtracking approach. Okay, just note it. We want to solve this using backtracking approach. Okay, here we studied using greedy approach how can solve a fractional knapsack. Here we want to study how to solve 0 bar 1 knapsack problem using backtracking. Okay, that is the difference. Similarly, there exist some other complicated problems. Okay, for example, traveling salesperson problem. TSP. TSP is a complicated problem. For solving that problem, we can use branch and bound. This is another problem solving approach, branch and bound. Okay. In the module 6, first we will study backtracking. Using backtracking, we can solve different optimization problem. Okay. And one is N-Queen's problem, another is 0 bar 1 knapsack problem, another is sum of subset problem. Sum of subset problem is another problem. Another problem is graph coloring. Okay, graph coloring is another problem that can be solved using backtracking. So there are different problems that can be solved using backtracking. So then in the next section we will study branch and bound approach. So this is another problem solving strategy. Then TSP problem we will use to solve that. Okay. We will study how to solve TSP using branch and bound approach. Okay. Then this is the first part of module 6. And in the module 6, the second part is not related to any approaches. It is related to you can note here this part. This part is related to another concept, that is introduction to complexity theory. Okay, tractable and intractable problems, the P class, NP class, polynomial time reduction, the NP hard and NP complete classes. Okay. This is not related to any problem solving approach. In this part, we will study different types of complex problems. Okay, we will deal with the complexity theory. Okay, and there exist some problems. It will take a polynomial time. We can classify the problem into different classes. P class and NP class. P means a polynomial time solver problem. NP means non-polynomial time, etc. Okay, this is the second part. Now today we want to start from the backtracking approach. Okay, today we want to study the backtracking approach. Okay. So okay, so this is backtracking. You want to use the textbook computer fundamental algorithms. Okay, fundamentals of computer algorithm. This is the textbook you want to use. Fundamentals of computer algorithm by Ellis Horowitz. Okay, so this first we want to study what is backtracking approach. Okay? What is backtracking, and one. In this, we want to study what is backtracking. Okay. So, what is backtracking means? So, this module 6 and backtracking. So, many problems which deals with searching for a set of solution or which ask for an optimal solution satisfying some constraints can be solved using backtracking formulation. Okay. So, which type of problem we can solve it using the backtracking approach, that we want to focus at first. Greedy approach is suitable for we studied where we will use greedy approach. Okay, where we will use greedy approach that we studied. Where we will use greedy approach for there are some particular type of problems that can be solved using the greedy approach. For example, fractional knapsack problem. Okay, we already studied that. Now, for which type of problems backtracking is suitable? That we want to discuss next. Okay, so this is the property. Many problems which deal with the searching for a set of solutions or which ask for an optimal solution satisfying some constraints that can be solved using backtracking formulation. Okay. So which type of problems we can solve using the backtracking approach? First we want to discuss that. Which type of problems we can solve. Okay. So we can solve the problems in this type. This is the nature of the problem. This type of problem we can solve using backtracking. That is, there is a set of solutions. Okay, there is a set of solution existing. From that set of solution, we want to find an optimal solution satisfying some constraints. Okay, that type of problems can be solved using backtracking approach. Just to try to compare it with the greedy approach. Okay, greedy approach. Greedy approach we discussed. Suppose there are n objects, then the problem solution consists of a subset of n. Okay, a subset of n that satisfies all constraints and it's an optimal and it will provide an optimal solution. That is greedy approach. Here, what is backtrack? Where backtracking can be applied means which deals with the searching for a set of solutions. Okay, that is the first part is there may exist different solutions. Okay, there may exist different solutions to a problem. We want to find the that set of solutions. That set of solution. Okay. Or second is or. First part we can use this type of problem. Problems which deals with the searching for a set of solutions. For example, you can consider this example. Okay. Suppose you already study permutation and combination. Okay. Suppose there are two boys and three girls. 2 boys and 1 girl is there. Okay. 2 boys and 2 boys. B1, B2, and 1 girl is there. Okay. There are 3 spaces there. Okay. This is 3 space. Okay. Okay, there are three spaces here. Then what I want to do is that uh, I want to find how many ways these uh, boys and girls can sit in this slots. Okay, just you try to imagine the situation. Okay, that is, there are two boys and one girl. In how many ways we can uh, arrange these boys and girls in this seats? Okay, this there are three seats. One, two, three. How many ways it will be possible? This is a basic permutation problem. How many ways it is possible? Okay, so this is a problem. Okay, for finding a solutions to this problem, we can use the backtracking approach. Okay, we can use the backtracking approach. That is, we want to find a set of solution to a problem. Okay. Additionally, suppose I am adding a constraint, a girl should sit in between two boys. Okay, I'm giving another problem. How many ways we can arrange in such a way that a girl should sit between two boys? This is another problem. Okay, this is another problem. Just imagine the situation. Okay, now the problem is constrained problem. That is, we want to find out in how many ways we can arrange boys and girls in such a way that a girl should sit between two boys. So we will get a different solutions. Okay. Okay, we will get a different solution. Then we want to find all such solutions. Okay, we want to find all such solution. In that case also we can use backtracking. Okay, just I am trying to just try to familiarize with for which type of problems the backtracking is suitable. It is not basically an optimization problem. It is used for finding it may be optimal, no problem, but it is suitable for finding a set of solutions that satisfies some constraints. Okay. For example, you can imagine this situation. This is a very simple example. There are two boys and one girl. There are three chairs is there. Okay. This is chair 1, this is 2, and this is 3. Now, the problem is in how many ways I can arrange a girl sit between two boys. This is a problem. This problem can be solved using backtracking approach. That is, we want to find a set of solution, not optimal solution. Okay, not need to become it optimal. Okay, sometimes it may be an optimal solution, but here there is no optimality here in this case. You can note that. Okay, so for solving this type of problem, we can use backtracking. That is, searching for a set of solutions. Okay, searching for a set of solutions. Okay, you can use this is the best example, I think, or which ask for an optimal solution. Searching for a set of solution satisfying some constraints. Okay, satisfying some constraints, or okay, this is enough actually. Okay, searching for a set of solution satisfying some constraints, or is an additional thing. The solution may be optimal, or which asks for an optimal solution. Okay, this is all. So this is the type of problem This type of problems can be solved using backtracking. Okay, so this, for example, I mentioned this example. Okay, this is a very good example actually. Hmm? So based on this, we can try to understand what is backtracking, etc. Okay. So this is the best example. There are two boys and one girl. I want to arrange them in such a way that a girl sit between two boys, or in that way. Okay. So finding solution to that problem, we can use backtracking. Then here, why I am using the textbook is that because here you can note the name backtrack was first coined by D.H. Lammer in the 1950s. Okay. While writing or using the notes, we will not write anything like this. Okay. We will never add some general knowledge in our notes. Okay. So just I'm using the textbook. Okay, the name backtrack, how the name backtrack, where it's originated, means it is coined by D.H. Lamar in the 1950s. Early workers who studied the process were R.J. Walker, who gave an algorithmic account of it in 1960s, etc., etc. Okay, so just note this history. Okay, this is just an history. Okay. So now we studied what is, for which type of problems backtracking can be applied. Okay, now I'm discussing some other problems also. Okay, I'm discussing some other problem. For example, which type of problem that can be solved using backtracking? Okay, basically it is used for solving very complicated problems. Okay, so one such problem is, we already studied one problem, that is 0 bar 1 knapsack. Okay, 0 bar 1 knapsack is a problem that can be solved using backtrack. Okay, we already studied what is 0 bar 1 knapsack. Okay, we already studied, so I'm not mentioning that now. We already studied that. Okay, fractional knapsack we defined, 0 bar 1 knapsack. We know what is knapsack problem clearly now. Okay, now another problem that we can solve it using backtracking is the N-Keynes problem. Okay, N-Keynes problem. N-Key. This is related to the chess game. Okay, so N-Keynes is a complicated problem that can be used to solve, that can be solved using backtrack. Okay, N-Keynes problem. Okay, so what is N-Keynes problem mean? There is a chessboard. Okay, this we want to study in the next section. We want to study how we can solve an N-Keynes problem using backtracking approach. Okay. So what is this problem means? There are N keys. N means it can be 8, it can be 4, it can be 2, etc., etc. Okay. As N increases, what will happen? As the size of N or number of keys increases, the problem becomes complicated. Okay. So this is one of the hard problem. Okay, I am using the term hard. Okay, hard problem. Okay, this is a class of problem which belongs to the hard problems in computer science. Okay, so N-Keynes is a problem which is related to the chess game. I hope you are aware about the chess game. Okay, so here the problem is there is a key. Okay, not only a single key. There are 8 keys. Okay, there are 8 keys here. If n equal to 8, then we call it as 8-queen problem. Okay, queen means that. Okay, queen means Radnia. Okay, so what is n means, or n can take 8, then it will become 8 queen problem. Okay, so you can note this problem. Okay, there are 8 queens. This is 1, 2, 3, 4, 5, 6, 7, 8. There are 8 queens, and this is an 8 by 8 size chessboard. Okay, this is an 8 by 8 size chessboard, and we want to arrange these queens. Okay, basically there are some constraints for placing the queen. Okay, so anyway, we want to place the queens in such a way that they will not attack each other. Okay, so that is the constraint. There are 8 queens. I want to place the 8 queens into the chessboard of size 8 by 8 in such a way that they will not attack each other. So that is 8 queen problem. So you can note here, this is a solution of 8 queen problem. So a queen can move in which direction? A queen can move in this way. A queen can move. Okay. Okay. In this way, a queen can move. Okay. That is, this is diagonal, this is horizontal or vertical. Okay. In this way, queen can move. In this way, a queen can move. In this way, a queen can move. These are the possible movements for the queen here. If I placed some other queen here, then what will happen? They will attack. That is not possible in this problem. So I want to arrange the queens in such a way that they will not attack each other. A queen can move diagonal, horizontal or vertical moves. But they should be placed in such a way that they should not attack each other. I want to find such an arrangement in the chessboard. So this is a complicated problem, and okay, this problem can be solved using which backtracking. Okay, so we will study that next. So this is also a problem that can be solved using backtracking, because this is one arrangement. Okay, this is one arrangement. You can note here in this figure, this is an arrangement, but there may exist other arrangements also. This is not only a single solution. There may exist several arrangements. That is, the solution is basically a subset. Okay, it is a subset. There exist different arrangements in such a way that the queens will not strike or attack each other. One of the solution is this. Okay, one arrangement is this. There may exist some other arrangement. So this type of problem can be solved using backtracking. Okay, that is matching to the backtracking type problems. Similarly, this is the approach we want to solve. Okay, just I'm telling the approach we want to solve. That is, for the problem we are considering, what we will do is that we create a state space tree. Okay, this is the state space tree of the n-queens problem. Okay, we will create this state space tree, then we will search the state space tree to find a solution. Okay, that is the backtracking approach. Okay, to solve this type of problem, and what the general approach is, what we will do is that we will create a state space tree by using some method, then search the state space to find the solution. Okay, this is the state space for this, that we will study next. Okay, so next, another type of problem we can solve it using backtracking is graph coloring problem. the graph coloring problem also we can solve it using backtracking approach, Hamiltonian cycles, etc. etc. There are different problems. Okay, so there are different problems we can solve it using. This is graph coloring problem. So this is a graph. We want to color each vertex in such a way that there should be, for example, I colored this is blue. This should not be blue. Okay, this should be different color. The neighbor should be of different color. Okay, that is graph coloring problem. This problem also we can solve it using backtracking. That is, there you can imagine the situation. That is, there exist different ways to color. Uh, of that is set of solutions we can find out. Okay, so this is also suitable for graph color backtracking. Similarly, another problem we can solve it using is sum of subset problem. Okay, that also can be solved using backtracking approach. Okay, anyway, in this module, in the first part, we will study what is backtracking. Now we studied what is backtracking means, or for which type of problem backtracking can be applied. It is used to solve problem to find a subset of the solution. Okay, we want to find a set of solution that is satisfying some constraints. Sometimes it may be an optimal. No, optimality is not necessary. Okay, for solving such type of problem, backtracking can be used. And NQ's problem, 0/1 knapsack problem, graph coloring problem, etc. Sum of subset problem, etc. can be solved using backtracking. Then the approach is, as I showed earlier, first we will create a state space tree. Okay, state space tree. Then we will search the state space tree to find a solution path. That is the approach we want to use. Okay, anyway, we can discuss that in the next class. Okay, next class we can discuss the next approaches. Okay, okay. Please give your attendance in the chat box. Okay, please give your attendance in the chat box. Starting from Akash Raji. Akash Raji, Vakananda. ഓക്കെ, അപ്പോൾ നിങ്ങൾ സ്റ്റഡി ചെയ്ത് തുടങ്ങുക. ഞാൻ റിപ്പീറ്റഡ് ആയിട്ട് പറഞ്ഞുകൊണ്ടിരിക്കുകയാണ്. ഇതുവരെ നിങ്ങളോട് ഞാൻ സ്റ്റഡി ചെയ്യാൻ വേണ്ടി പറയാറില്ല. സോ നിങ്ങൾ സ്റ്റഡി ചെയ്യേണ്ടത് ഇനി മുതൽ വളരെ സീരിയസ് ആയിട്ട് സ്റ്റഡി ചെയ്യുക. ഓക്കെ, വളരെ സീരിയസ് ആയിട്ട് സ്റ്റഡി ചെയ്യുക. ഓക്കെ, ഇപ്പോൾ റിവിഷൻ പ്ലാനൊക്കെ സെറ്റ് ചെയ്തിട്ടാണ് ഇനി മുന്നോട്ട് പോകുന്നത്. ഓക്കെ, താങ്ക് യു. സാരംഗ് ആബ്സെന്റ് ഇടുന്നുണ്ട്.
സാറേ, അറ്റൻഡൻസ് ഇട്ടിന് കുറച്ച് ലേറ്റ് ആയി. സാറേ ഫുഡ് കഴിക്കുന്നേനു താഴേനു അതാ അറ്റൻഡൻസ് ഇടാൻ വൈകി.
എന്താ പ്രശ്നം?
സാറേ അറ്റൻഡൻസ് ഇട്ടിന് അതിനാ
ആ ഞാൻ
താഴെയായിരുന്നു.
കണ്ടു
ഓക്കെ സാർ.
കണ്ടു.